These are some sample review problems for exam 1. First, evaluate the limit x goes to infinity, of 12x to the 6 minus 10x cubed plus 7x to the 5th minus 2 over 12x to the 5th plus 4x to the 3rd minus 6x squared minus x minus 8x to the 6th. First, we'd try to plug in the limit. So plug in infinity for each x. But what would happen there is you would get plus or minus infinity over infinity. I just wrote plus or minus to show we could end up with like a positive infinity on top or bottom, or a negative infinity on top or bottom, depending on the side of the fraction here. And this is a form that we cannot determine, infinity over infinity, so we have to do something else. And there are a couple things that you could try to do. So you could try to factor. This looks challenging to factor because of the high powers. So another thing that you can do is you can look for the highest power, which I see in x to the 6th, nothing higher, and multiply in the numerator and denominator by 1 over x to the 6th. That's not going to change the quotient, it's just going to change how it's written. So I'm going to multiply the numerator and denominator by 1 over x to the 6th and then rewrite the limit. So this would become, in the numerator, limit x goes to infinity of 12x to the 6th over x to the 6th minus 10x to the 3rd over x to the 6th plus 7x to the 5th over x to the 6th minus 2 over x to the 6th. That's the numerator. The denominator becomes 12x to the 5th over x to the 6th plus 4x to the 3rd over x to the 6th minus 6x squared over x to the 6th minus x over x to the 6th minus 8x to the 6th over x to the 6th. And then we can simplify each of these pieces. So when we do that, we would get limit x goes to infinity. In the numerator, we would get 12 minus 10 over x to the 3rd plus 7 over x minus 2 over x to the 6th. In the denominator, 12 over x plus 4 over x to the 3rd minus 6 over x to the 4th minus 1 over x to the 5th minus 8. So now when we think about plugging in this limit as x goes to infinity, any of these individual terms that has an x or an x to a power in the denominator is going to go to 0. 10 over x to the 3rd, that whole term is going to go to 0. This term is going to go to 0. This term is going to go to 0. So anything with an x in the denominator will go to 0. And what remains then, when we think about evaluating the limit at infinity, is 12 in the numerator over negative 8. So only those constant terms remain when we evaluate the limit at infinity in this way. 12 over negative 8, that reduces to negative 3 over 2. So that is the final answer for this limit. Problem 2, find the derivative of f of x equals 4 times the square root of 6x to the 3rd minus 5. I like to rewrite square root problems with fraction exponents. So this would be f of x equals 4, 6x to the 3rd minus 5 to the 1/2 power. And then we're going to do a substitution. So we'll let u equal this polynomial in parentheses, u equals 6x to the third minus 5, and then u prime would be the derivative of that, which is 18x squared. So then f prime of x, or I'm going to rewrite f of x, would be 4u to the 1/2. So f prime of x would be 4 times the power of u times u, subtract 1 from the power, that would be negative 1/2, times the derivative of u prime. And we can simplify that a little bit, the 4 and the 1/2, so it's going to be 2u to the negative 1/2 times u prime. We can rewrite that differently as well. We can write it as 2u prime over u to the 1/2. Okay, let's plug back in u and u prime. So f prime of x will be equal to 2 times u prime, which was 18x squared, over 6x to the third minus 5 to the 1/2. I'm going to rewrite this as 36x squared over square root of 6x to the third minus 5. And that is our final answer for f prime of x. Okay, write the equation of the tangent line to the function f of x equals 5e to the x squared minus 1, where x equals 1. So to write the equation of a tangent line, we're going to need the derivative. So we're going to find f prime of x. Before we do that, I'm going to do a u substitution for the exponent. So I'm going to let u equal x squared minus 1, and that will make u prime equals 2x. So then our function is f of x equals 5e to the u. And then we can take the derivative. F prime of x equals 5e to the u, since the derivative of e to the x is just e to the x. Then we multiply by the derivative of the exponent u prime. So plugging back in, we'll get f prime of x equals 5e to the u, which was x squared minus 1, times u prime, which was 2x. We can rewrite this as f prime of x equals 10x e to the x squared minus 1. And now we want to write our tangent line. So just to recall, one of the easier ways to find the equation of a line is y minus y1 equals m x minus x1. There are, of course, other ways to do it. So we need 3 things. We need m, and we need x1 and y1. So to find m, well, the only thing that we have right now is x1. So to find m, we plug in x1 into the f function, or f prime function. So m is going to be f prime of x1, or f prime of 1. So that just means plug in 1 to our derivative function here. So 10 times 1 times e to the 1 squared minus 1. That's going to be 10 e to the 1 minus 1, or e to the 0, which is just 10. So our slope for our line is going to be m equals 10. The other thing that we need is y1. y1 we can find by plugging in x1 to the original function. So y1 is going to be f of x1, which is 5e to the 1 squared, since we're plugging in 1, minus 1. This is 5e to the 0, which is just 5. So y1 is equal to 5. So we now have our x1, y1, and m values to find this line. y1 is 5, x1 is 1, and m is 10. So our equation in, this is called point slope form, is y minus 5 equals 10 times x minus 1. In general, you want the equation of the line to be in slope-intercept form, so y equals mx plus b. So we need to do some solving here. So y minus 5 equals, distribute the 10x minus 10, and then move the 5 over. Y equals 10x minus 5. So this is the equation of the tangent line when x is equal to 1.